Today we're gonna test language models to their limits. I built a chess simulator that takes the state-of-the-art AI models like Gemini, GPT, Claude and Grok, puts them through hundreds of chess puzzles and makes them play in a head-to-head tournament against each other. Then we will crown one model as the ultimate AI chess player. And a quick spoiler, one model was way better than all the others. I actually asked you guys in my survey what model you think is the best. Claude got most votes, Grok got none. And I think you'll be very surprised about the results. With this simulator, we can not only figure out which AI is best at playing chess, but also estimate each model's chess rating. And that's very important because it gives us a metric we can track over time to better understand how these models improve with new versions in the future. Why do we care? Well, we need some way to measure AI's performance. And for that, we have benchmarks like MMLU and MMMLU and SweBench and about a million others. But here's the thing, evaluating AI is actually really hard. I would even say the field is in a little evaluation crisis. And don't get me wrong, lots of smart people are working on this, but there are still some big problems to solve. Problem 1, data contamination. Benchmark questions and answers can leak into training data, and suddenly models can basically cheat. They've seen the answers before. And this is really hard to prevent because AI companies scrape basically the entire public web. There is even something called a canary string, a little tag you put into your dataset that says, please don't train on this. But I don't know if they always listen. Problem 2, saturation. Once models hit 90% plus on a benchmark, it's basically useless. There is no headroom left. Take Humanity's Last Exam, a horrible name by the way. When it came out last year, GPT scored around 2%. Now, a year later, Claude scores 65%. So next year we'll need the last exam probably. But I think I have a solution to all of this. And you can probably guess it. Chess is an excellent benchmark for AI reasoning. Let me explain. First, we can just have LLMs play against each other, which means we don't have to worry about data contamination and memorization because there are more possible distinct chess games than there are atoms in the universe. By the way, the number of distinct chess games is called the Shannon number, proposed by Claude Shannon in the 50s, and in his paper he estimated that there are 10 to the power of 120 possible chess games. That's a lot. That means LLMs can't just memorize chess, they actually need to learn it. They can memorize all the openings maybe and be good for the first, I don't know, 15 moves, but then they are on their own and need to start reasoning. Second, saturation is not an issue either. Yes, we have chess engines like Stockfish and AlphaZero that can play perfect chess, but LLM architecture is so fundamentally different. And I think it will take a long time before ChatGPT can beat top chess players. And this is important to understand because people nowadays think that AI can just do anything. So before we get to the games, let me very quickly show you the difference between an AI designed to play chess and a general AI like Claude or GPT. 10 years ago, in 2016, DeepMind officially introduced the model AlphaGo and organized the famous match against Lee Sedol, where AlphaGo won 4-1, beating one of the greatest players in the history of Go. A year later, DeepMind released AlphaZero, a successor to AlphaGo that learned entirely from self-play and could also play games like chess. Both AlphaGo and AlphaZero approach these games as a search problem. If we visualize it so that a single node in this tree chart represents a single chess position, the model continuously explores the most promising positions and then scores them. AlphaZero doesn't generate tokens like a standard LLM. Instead, it has exactly two outputs. One that suggests which moves are worth exploring, and one that tells you who is winning in a given position. So put simply, you explore the most interesting moves, you score them, you do it thousands of times, and your final move is the one where the overall exploration gives the best scores. You can see how specialized this system is and why it works. If you can consider tens of thousands of positions and accurately tell who is better in each one, that is very powerful. Now compare this with LLMs. This is me running GPT-OSS locally on my laptop. I asked it to tell me the best move in the specific chess position it received, and you can see the reasoning output here in real time. Not only can it not process thousands of positions, it's already struggling to understand the one I gave it. It took about a minute to even figure out where the pieces were placed. And when we look at the reasoning, it's trying to think about where pieces go, even considering moves like king to a0. There is no a0, it starts with a1. But overall, it's trying to think about chess much more like a human would. Only this model is very bad at it. And similar to humans, for an LLM to play chess well, it has to be really good at reasoning. It must be able to understand the position, be aware of tactics and long-term plans, and consider alternatives. It doesn't have an architectural shortcut to analyze thousands of positions in a second. So hopefully, I've convinced you by now that chess is an excellent benchmark for LLM reasoning, so let's play some chess. I selected 8 of the most powerful AI models out there. GPT, Gemini, Claude, and Grok are proprietary models. Qwen, GPT-OSS, GLM, and DeepSeek are open source. Now, 8 models is quite a lot for a tournament, so as the first step, I'll make them to solve hundreds of puzzles, and only the top 4 puzzle solvers will be allowed to play against each other. But where do I get these puzzles? Well, it turns out that Lichess has an amazing publicly available database of chess puzzles. They analyzed 600 million chess games, used more than 100 years of CPU time on stockfish to select the interesting ones, and then gave them to humans to solve. And with every human attempt to solve a puzzle, they improved the estimate of how difficult that puzzle is. And this is absolutely brilliant, because if you've watched my previous videos on chess, you know I've been trying to estimate AI's chess rating over the years by playing against chessbots, but it was really difficult and expensive to get it all running. But now we have basically unlimited chess puzzles, highly correlated with human performance, and we can just have each AI solve hundreds of them really fast and estimate its rating. So I collected a bunch of puzzles and sorted them into 3 difficulty categories. Easy for ratings up to 1000, medium for puzzles rated from 1000 to 2000, and hard for puzzles rated more than 2000. By the way, if you're not familiar with chess ratings, the most common one is called ELO. That's the rating system used in professional chess tournaments. The distribution for blitz games looks like this. The absolute minimum you can have is 1400, an average player has about 1500, and the number 1 player, Magnus Carlsen, has a blitz ELO rating of 2860. Now, this is one system of measuring rating, and the one used online is slightly different. Both chess.com and Lichess use the Glico rating, and you can see the distribution is similar but a bit different. The minimum rating is 400, an average player has about 1700, and Magnus, who plays on Lichess as Dr. Nichternstein, has a rating over 3100. So basically there are different systems, I'll be using the Glico one, and we're good as long as we compare everything using the same rating system. So let's start with the easy puzzles first. You can see 8 models all solving 20 easy puzzles. And again, these are very easy puzzles. For example, take this one, a very simple mate in 2 on the back rank like this. All these puzzles are up to 1000 Glico rating, which is this small area of the distribution. So I was actually expecting all models to score close to 20 points. But that wasn't the case. Here are the results. GPT and Gemini did almost perfectly. I'm okay with one mistake, but all the other models did quite poorly. Even Claude and Grok with 17 out of 20 is not a strong result, and all the open source models did really badly. GPT-OSS, which I showed you earlier, wasn't even the worst. DeepSeek scored only 5 out of 20. Even though I'm a big fan of open source models, there seems to be a huge reasoning gap between DeepSeek and GPT. So these were the easy puzzles, and we already have 4 winners. There's no need to run the harder ones. However, you guys previously mentioned I should test more types of inputs and play more with prompting. So I actually tested 3 different types of input. The results you just saw were for FEN input. FEN is a single string that looks like this, and it directly represents a unique chess position. It's very compact, but maybe it would be better to provide some visual signal as well. So I ran the same puzzles again, but this time I gave the models FEN and an ASCII representation of the board. And I was quite hopeful here, but it gave surprisingly similar results, both 66% on average. But you can see that for our top winning models, the numbers are actually slightly worse here. And the last thing I tried was giving them FEN, the ASCII board, and also a list of all available legal moves the AI can play in that position. And the results were much worse this time. Look at Claude, it dropped from 85 to 65%. This is a great example of how important prompting is, and that more is not always better. You would think that adding more information is always beneficial to the model, but I looked at some reasoning traces, and what happens is that if I give them a list of all possible moves, the models just get confused exploring every single one instead of, well, trying to solve the puzzle. Great, so now we have our 4 winners, we did the hard work, we know that FEN is the best input representation for our models, let's make them play against each other. So I made this website that gives us the initial random pairings, and so we have GPT 5.4, Gemini 3.1, Claude Opus for 8, and Grok for 20. And we draw the pairings. And the matchups for the first round are Grok versus GPT and Gemini versus Claude. By the way, if you're wondering why I didn't use the absolute latest models like GPT-Sol or Claude Fable, well, that's because they are so much more expensive. And this experiment already burned through tokens like nothing. So if you like this content and want to see the absolute latest models next time, please consider subscribing. And if you want to support the channel directly, I also just launched a Patreon page and the link is in the description below. But let's go back to chess. So here are the games being played in the simulator. Each match is a best of 2, 1 game with each color, and if it's a tie, we play more. For each move, we give the model the updated FEN position and also the list of all previous played moves, which is something we didn't have for puzzles, of course. And you know, this is an AI channel, not a chess channel, but let me show you some of these games and how the models played, because it was absolutely fascinating to watch their decision making, and these games reveal a lot about how these models reason. So this is GPT with the white pieces and Grok with the black. And the first moves are some variation of the Queen's Gambit declined, not very interesting to me because I would expect the models can just memorize all of this. But now GPT gets very greedy here, focuses on this pawn and plays c7, which is a huge blunder because Grok can now take and is in a much better position. However, Grok immediately gives up all that advantage by trading everything away. Rook a c8 is another big blunder because GPT can play bishop a6. And now white can do something like bishop b7 and then double up the rooks and have a very active position. The engine gives it +4. Instead, what do you think GPT decided to play? I've been watching AI play chess for a while now, so the moment I saw this position, I knew that the idea of promoting a pawn is such a strong signal in the reasoning traces that the model might just fall for it. And of course, we have 3 attackers, 2 defenders. GPT just lost the pawn for nothing. And now it's just a draw. I mean, it was a draw until GPT played this and lost its rook for a pawn. Now black is completely winning. But Grok got inspired by the rook sacrifice earlier and did the same thing. Oh dear. Fortunately for black, this position is still completely winning and actually very easy to win because white can't really take these pawns. Let's say we let the white king grab one. Black just starts running and will promote. But Grok being Grok played this and gave them both away. That's such a non-human move. And it's a draw. So after this game, I was a little bit worried the whole tournament would look like this. Both sides making huge blunders, losing all their pieces and drawing every single game. But fortunately, this was the only draw of the tournament. So with the first game tied, everything comes down to game 2. Colors reversed, Grok with the white pieces. And this game is faster and decisive because one model plays much worse here. It starts pretty normally until Grok sees this check and completely ignores that black can just take the bishop for free. And then Grok loses a knight and a rook. But okay, we're at move 23 and even though white is down a rook and a bishop for 2 pawns, it has lots of activity and the black king is weak. You can still lose this as black. I know I probably would, but now take a second, think about everything we've just seen and try to guess Grok's next move. Yep. Grok played this. And this tells you a lot about how well Grok actually understands the position. It clearly identified that this is a mating square and that the queen can deliver checkmate here. But it didn't go that one step further to check whether the square is defended by another piece. So that happened and then GPT actually delivered a surprisingly quick and clean checkmate. So with 1.5 to a half, and especially after that nice mate, GPT takes the match and goes to the finals. And that's our first finalist. Now the other half of the bracket, Gemini versus Claude. And remember, Claude was your favorite in the survey, so let's see if it can deliver. We're starting with the Sicilian Najdorf, an opening that often leads to opposite side castling, and that usually means quite aggressive games. So far so good, but rook c8 by Claude is actually a pretty bad move, because Gemini can now trade its rook for 2 pieces, either like this or like this. Taking the bishop is better because it doubles black's pawns, and it found it. Wow, white is much better now. And wow, what is going on? Wow, black completely resigned. That was fast. This game felt different. Gemini just completely steamrolled Claude here, so let's see if Gemini can do this again. The second game was another Sicilian, and very quiet for the first 20 moves. And then Claude did this. And just look, it completely forgot about his bishop. So far, every model except Gemini keeps making these mistakes, forgetting about the opponent's pieces. Now it's completely lost, of course. So let's see if Gemini can convert it. Rook to f6, another huge mistake. Claude doesn't see the queen. And you know, it gets the position in FEN, so seeing the queen shouldn't be the hard part. And now there is mate in 2, and Gemini finds it. And that's 2 wins for Gemini, so it goes to the finals. Seeing these two games was very interesting to me because Gemini was just solid, playing reasonable moves overall, finding mates, staying active, and Claude was making loads of mistakes, greedily taking pieces, forgetting the opponent's pieces, and I know it's just 2 games, but you can see a big performance gap here. Gemini is simply much better at playing chess. So Gemini seems to be in good shape this season, just like Sindarov in The Candidate. But maybe Gemini just got lucky, facing an opponent that was giving away pieces for free. After all, both Gemini and GPT scored 19 out of 20 on the puzzles. So at least, in that category, they were equally strong. Alright, let's see what happens. Gemini versus GPT, let's go. And our models didn't disappoint, we can see another Najdorf. And you know, I'm optimistic, that's a solid start from both models. And here we go again. Oh no, this is so hard to watch. Okay, I have something to say here. I'm not gonna comment on GPT's performance anymore because it's just dismal at this point. Gemini is doing really well, checkmating the king in the middle of the board. A year ago, AI would try to checkmate like this and lose all its pieces in the process. And it's done. This sequence wasn't optimal, but it looked very natural to me. And in the last game, nothing crazy happens. GPT just miscalculates the fight in the middle of the board and loses a piece in the process. And we've already seen that when Gemini is given a big advantage like this, it can convert it. It's not gonna blunder its queen or something. Now look at this sequence. Gemini develops its bishop, then snacks a pawn, then munches on another one, and then pins the rook and takes it. Amazing. Gemini is completely dominating this game. It promotes a queen and checkmates. And that's it. With a clean 2-0 in the finals, Gemini 3.1 is officially our tournament champion. But hold on, winning the tournament is one thing. What's Gemini's actual chess rating? Well, that's what we'll figure out next. Now it's time to use the medium and hard puzzles. So I gave Gemini 50 medium puzzles. That's ratings from 1000 to 2000. And wow, it did really well, 44 out of 50. That's 88% on puzzles that are substantially harder. I'm actually pretty impressed and curious about the hard puzzles now. These are rated 2000 and up. We're getting into the territory of really strong players. And here Gemini finally hit a wall, 16 out of 50. Still not nothing though, these are genuinely difficult puzzles. And based on all these puzzle results, we can now estimate Gemini's rating. And the number is 2087? Wow. Okay, I'm slightly skeptical here. Okay, so I did some reading and it seems that puzzle ratings tend to be a little higher than actual chess ratings. Now, of course, these two are still correlated and we can keep using this rating to track AI models over time. It just means that 2087 probably maps to something like 1900 in real playing strength, which is still a lot for a language model. And for context, last year I estimated GPT-4o's rating at about 1800. Chess reasoning is improving really fast. Now, one thing we need to be careful about here is data contamination. When the models play against each other, that's not a problem, because every game is unique. But puzzles, the Lichess puzzle database is public, which means models could have been trained on it. Now, so far it doesn't really look like it. If a model had simply memorized the answers, it wouldn't be scoring 16 out of 50 on the hard ones. But honestly, it's hard to rule out completely, and it's something I need to think about. And actually, let me know in the comments what you think, or if you have ideas for how to test this better. Anyway, I hope you enjoyed the video, please consider subscribing, and thank you for watching.